everyone. I am so excited that you are all here. If this is your first activity for the day, I am excited for all the cool things that you're going to learn. And if it's not, I hope you've been having a lot of fun and continue to have fun with us. Before I start my presentation, I want to tell you a little bit about who is going to talk to you today. My name is Daniela Rodriguez. I got my 4-year degree at the University of Nevada, Las Vegas, and during the time I was getting my 4-year degree, I worked for Dr. Tseng, and after graduating, I continued working with her as a researcher. There are 2 other people that will be talking to you in today's presentation. Both of them are students. Dina is doing what I did and is working on getting her 4-year degree and works in Dr. Tseng's lab as a researcher. Dina will present her cool at-home activity after me. Erin is getting her degree to become a professor. And if you're wondering what a professor is, it's a teacher at a university, and some professors have their own laboratories, similar to what Dr. Tseng does. Finally, I want to introduce the rest of the lab members that also work with Dina, Erin, and myself. Here is Melissa, there's Leo, and finally there's Kanisha. Now that I have introduced all of us, we will jump right into it. Today, I will be talking to you about bacteria, the good and the bad. In this presentation, you will learn about bacteria, some vocabulary regarding bacteria. We will discuss where we can find bacteria, as well as good and bad examples of bacteria. And finally, we will talk about bacteria that live in communities called biofilms. And at the very end, we'll summarize everything that we learned. And afterwards, Dina will take over and talk you through how to make yogurt at home. So first, let's talk about bacteria. What even are they? Before we talk about bacteria, let's zoom out a little bit. I want you to take a look at your dad, your mom, your grandma, your grandpa, sister or brother, or just look at yourself. Scientists call you and me an organism. An organism, by definition, are people, animals, plants, or bacteria. It's basically any one thing that is alive. Now that we have zoomed out, let's zoom back into our presentation. Let's talk about microorganisms. If we break down the word into micro and organism, we get the meaning. Micro means teeny tiny, something that you can only see with the help of a microscope. And microscope is kind of like a super powerful magnifying glass. The other part of the word is organism. We just discussed what organism is, and now you know the meaning of it. It's any person, animal, plant, or bacteria, or basically any one living thing. Smash the words together and you get teeny tiny living thing. And in this case, we're talking about bacteria. So to reiterate, one type of microorganism is bacteria. Now let's talk a little bit more about this microorganism. They come in all different shapes and sizes. And here I'm going to use the terms that scientists use to describe different shaped bacteria. This is a bacillus-shaped bacteria. It looks like an oval or a stretched out circle. There's coccus-shaped bacteria. It's very spherical shaped, or just basically a circle. There is beryllium-shaped bacteria. It twists and turns like a spiral. And you aren't going to believe what I'm going to say next, but there's even spiky ball-shaped bacteria. As you can see here, there's a lot of diversity of different shapes, and there's a lot of other bacteria shape that I didn't talk about today. The final thing that I want to talk about is the word bacterium versus the word bacteria. It's similar to the word dog versus the word dogs. When you say the word dog, you're talking about one. When you say the word dogs, you're talking about 2 or more. Similar to the words bacterium, you're talking about one when you say bacterium, and when you say bacteria, you're talking about 2 or more. All right, we talked a little bit about bacteria. Now let's move on to where we can find this bacteria. Drum roll, please. You can actually find bacteria everywhere. Any surface that you can put your hands on, there's probably bacteria there. Your couch, your pillows, or your door handles, your kitchen table, and your tub. One of the places where bacteria can be found a lot and can be found different kinds of bacteria is in soil. Here's another really great part of where you can find bacteria. You can actually find it on your skin, in your mouth, in your nose, and even in your stomach. We can also find bacteria in our food. In the next 2 slides, I'm going to expand on the good and the bad bacteria. Let's talk about good bacteria first. We actually have a lot of bacteria in our gut, or our stomachs and intestines. There is bacteria in our intestines that help us make vitamins that we really need, such as vitamin K and vitamin B12. Now, we do have some bad bacteria in our gut, but because of our good bacteria, the bad bacteria are not able to make us sick. They make sure that there's more good bacteria than there is bad bacteria, and like I said, keep us from getting sick. Good bacteria is in some food that we eat as well. Good bacteria is found in yogurt, in cheese, and kombucha. And kombucha is a type of tea. Now, what all these foods have in common is that they have what is called probiotics. The definition of probiotics is an amount of live good bacteria. And yogurt, cheese, and kombucha definitely have live good bacteria. So therefore, by definition, these foods have probiotics. Now let's talk about the bad bacteria. But before I go on, I want you to always remember the good bacteria we just discussed, because when people think of bacteria, they always assume that it's bad. But you saw on this slide all the good that good bacteria can do for you. So don't forget it. Moving on to the bad. There are some bad bacteria that can be found in your mouth. Have you ever wondered, why do you have to brush your teeth? One of the reasons is because you want to get rid of the bad bacteria that are on your teeth. Otherwise, these bacteria can cause some major damage. Let's discuss what they do a little more. Here we have a drawing of healthy teeth. Now let's say you haven't brushed your teeth and don't want to brush your teeth. And now you have bacteria growing on a specific tooth. This tooth here, we have it zoomed in now. You have bacteria growing on it, and maybe you're thinking, no big deal, right? But it's a really big deal. Now this bacteria is breaking down the surface of your tooth and is slowly but surely making a hole in your tooth. And now you have a broken down tooth, which can continue to spread even onto another tooth. And finally, you have teeth that are so broken down because of the bacteria that you have to get rid of them. And I don't know about you, but I really like my teeth and would like to keep them as long as I can. That's why you have to make sure to brush your teeth. So far, we have talked about bacteria, where we can find it, and the good and the bad. Now let's talk a little bit about the bacteria that live in communities. So when you talk about bacteria in the beginning, we talked about the size and how they are teeny tiny. Well, frequently on different surfaces, we can find bacteria living in communities. Now, for the bacteria, this is usually a good thing, because thinking about such a tiny organism in such a big world, it would make sense to work together with other tiny organisms to survive. By living together, they locate a place to live and protect each other from the different dangers in the environment. They also share different resources, and they produce more of themselves, which is a good thing for the bacteria because it means that they're not dying off. These communities of bacteria are held together by a slime that the bacteria make themselves. And the slime with the bacteria in it is called a biofilm. These biofilms can be found in different shapes. There are biofilms that look like mushrooms, some that have a dome shape, and some that are much flatter and closer to the surface that they are attached to. All right, we have completed our presentation. And to summarize, we went over what bacteria are, the different shapes of bacteria, as well as the differences between the words bacteria and bacterium. We talked about all the different places you can find bacteria, the good and the bad, and finally we talked about communities of bacteria make their own protective slime called biofilms. With this presentation, I have attached a handout where you can draw your own communities of bacteria in their slime. Thank you all for your attention, and I will pass this presentation on to Dina.
Hello, I'm Dina. I'm going to show you how to make yogurt using good bacteria. Earlier, Daniela told you all about good bacteria and the various things that they can do for us. One good thing bacteria can do is make food. Bacteria help make all kinds of food, and one of them is yogurt. There are two bacteria that work together to make yogurt. How do they do this? Well, they break down the sugar found in milk and turn it into acid. This produces the tanginess of yogurt. Now that we know how the bacteria turns milk into yogurt, let's try it for ourselves. You'll start with a saucepan, preferably one that can hold 1 liter of milk. Then you pour your half gallon or 1 liter of milk into the saucepan. Okay, now that you have your milk in your saucepan, you can ask your parent to turn on the burner. If you have a thermometer, this is when you would put it into the milk to make sure that it gets up to the proper temperature. If you don't have a thermometer like I don't, then you'll watch it to make sure that it doesn't boil over. So, 1 liter of milk is a lot of milk to heat through. It's going to take a few minutes. But once it starts to boil, it'll bubble first on the top, and then it'll come to a rolling boil. If you have a thermometer, don't let it get to the boiling point. Just get up to the heat on the thermometer. While you're waiting for your milk to get up to the right temperature, you can prepare your yogurt. Yogurt, as it's sitting, will separate. You want to mix it thoroughly before you add it to your milk. Once your milk starts to boil, turn off the burner and move it to a burner that's not on. Then you're going to take 5 spoonfuls of yogurt. Okay. Not necessarily heaping, but more than a leveled spoon. So 1, 2, and I'm tapping it on the side of the pan just to make sure that as much of it gets off as possible. 3, 4, 5. Now, once you have put your yogurt into your milk, make sure that you mix it thoroughly. There may be a slight film on the top of the milk because it was heated, but it will mix into the yogurt and you won't even notice it. It's part of the thickening process. So make sure that your yogurt is no longer in the spoonfuls. You want it to be a smooth consistency. And I'll show you what we're working with. Okay, so you've added your yogurt and now you're mixing. You want to mix slowly as you see it starting to curdle, and make sure that it is all mixed in. At this point, you can take a whisk and softly mix through. This will help break up the clumps and ensure that the yogurt is thoroughly mixed in. Now that we've whisked the yogurt, it is smooth and there are no visible clumps. This is the consistency that we want. Now, if you don't have a thermometer and you boiled the milk instead, you will notice some yellow pieces in the milk. This is completely natural and there's nothing to worry about. The reason cow milk turns yellow when it is heated is because of a pigment in the milk. It is completely natural, and actually raw milk is yellow in color. It doesn't turn into white because it's not as pasteurized as regular cow milk that we would find in the grocery store. Now that you have thoroughly mixed your yogurt and your milk together, you're going to let your mixture cool down. Our target temperature is about 100 degrees Fahrenheit. So those of you with a thermometer, keep the thermometer in your mixture, and once it gets down to 100 degrees Fahrenheit, you can cover the mixture and move on to the next step. If you do not have a thermometer, take a spoon. I'm using my yogurt spoon. I just rinsed it. Put it into your mixture and make sure that it doesn't fall into it so that you can touch it. So the mixture should heat up the spoon, and you're going to want to have your parent do this part. As it is cooling down, periodically touch the spoon. If it's cool to the touch, then it is about the right temperature. If you can handle it without it being too warm, then your mixture is most likely at the right temperature, and you can move on to the next step. Now, for this next step, it is about keeping your mixture warm for a long period of time. If you are using your oven, you're going to set it at 100 degrees Fahrenheit. If you are using your oven, you can go ahead and place your cover on top of your skillet and place it into the oven now. Make sure that any skillet or pan that you use for this doesn't have a plastic handle, as it will melt in the oven. Once you have allowed your mixture to sit, you can give it a really good stir. If the consistency is still runny like milk, let it sit in the heat for a longer period of time. If it is thicker like yogurt, you can put it directly into the fridge. Now, in order for your yogurt to cool all the way through, you'll want to let it sit for 12 to 24 hours. That way you can ensure that it is okay to eat. I really hope that you enjoyed this experiment, and I hope you enjoy your yogurt.
Hi everyone, I'm Erin. I work in the Tseng lab at UNLV, and I research bacteria. Today we're going to do a little experiment with my daughter Georgia, who's 10, and my son Will, who's 8, as well as our puppy Luna and our old dog Stella down here. We're going to see what kind of bacteria other little bugs might get on your fingers when you do the kinds of things that you like to do every single day. So let's go have some fun. Okay, so now we're back from the park, and what we're going to do for our experiment is we have these petri dishes that are used to grow bacteria, and they have food for bacteria on the inside. So what we're going to do is with each kid's hand, we'll take one hand and use either hand sanitizer on it or wash it, and we'll leave the other one dirty from the playground. And they're going to touch these plates and we'll see what grows on them. So Georgia, put hand sanitizer, oh my goodness, on this one, leave that one dirty, okay? And Mommy will wash it so you can keep your other hand dirty, okay? And when is the next time in your life you will ever hear me say that to you? Can you put these fingers from your left hand on there?
The fingers or
Just the fingers. I don't think your whole hand will fit. So kind of flatten your fingers down. You don't need to push into the agar. Maybe kind of roll them around a little bit. And do the same thing that you did with your other hand with this one, okay? So roll your fingertips around on there. Take our little paw and put it right on there. Boop, boop. What is that, Lon?
No, eating it.
Yes.
No, eating it.
What is that? Oh my goodness. And then we're just gonna stick it right. Oh, baby. Oh, the touch of a girl. Okay. Close it up. Good job. You're such a good girl. We set up a camera to take a picture of our plates every 10 minutes for 7 days. Bacteria and other microscopic organisms usually take a little time to grow in a new place, like these petri dishes. During this time, they're adjusting to things like all the fresh food and warmth and light around them. But as we can see now, when microscopic organisms start growing in this nice new environment, wow, they really grow fast. They make many, many identical copies of themselves, which become groups of organisms that we call colonies. Microbiologists are scientists who study microscopic organisms, and we use the way colonies look to learn about them. So things like how fast they grow, what kinds of food they grow best on, or how they interact with other organisms around them. Hey, did you notice that? What the heck happened to that plate in the corner? Well, here's a little secret. Science doesn't always go the way we plan, especially when you have a mischievous little 5-month-old puppy in your house who steals everything. Remember Luna? Yeah, the puppy ate our experiment. Super gross, right? Don't worry, she's fine. Now, we're going to investigate our results. So, are you guys ready to take a look and see what grew on your plates?
Yes.
Yes. All right. First, we have Georgia's sanitized plate. So what is it? Ew.
Look at this. Oh, that is disgusting.
Okay, move your hands so we can see in the light, okay? Let's see.
It's so
disgusting.
Hand sanitizer does not do the job.
Hand sanitizer does not really do the job, huh? So what do you guys see here? Let's describe what we see.
I see
Whole lot of
fungi.
Yeah, so why do you know it's fungus?
And some
Because
bacteria over here.
it seems like it's like white and fluffy, and I think
Yeah.
fungi is also sometimes white
This
and
looks
fluffy.
like
Yeah, when
big
the fungus-
bacteria.
Yeah, those guys look like bacteria to you. So how would you describe those? Those are called colonies. So how would you describe them by the color that they are?
I
I
would describe them as round and squishy.
Oh, they look kind of squishy to you. So these colonies, we see different colors. So I see yellow, I see white, I see off-white, aside from our big fungus friend there. That is one giant piece of fungus.
It looks like fungus and bacteria mixed together right there.
Yeah, right. Like they're living together. I mean,
Yes.
separately, right? Because it's not like they mix together. So what else do we see, guys? So we see different colors. Do we see different textures? Are there different,
Yeah, because it seems like the white is more puffy, and the yellow is more like
Is a little more like squishy or maybe
hard.
It might be hard. It might be hard.
and
Now look at this guy over here. Do you see this guy on the other side of the fungus? Hold on. Ooh, yep. Look at the top of that colony. Do you see that right there? Do you know the one that I'm talking about?
Yeah, the small
There,
one.
the small little white one. Look at the top of that guy. It has like a ridge on it, doesn't it?
Yeah, what happened to him?
Isn't that interesting?
maybe they built a building.
Yeah, it is. It's almost like they built a building. All right, so do we want to see another plate now?
Yeah.
Okay. Let's see. What's this one?
Mine.
That is William's dirty hand.
Look, it looks wet there.
Yeah.
There's so many textures on it. This one looks like coral right there.
Oh
Yeah.
God, that one looks like a spider. web.
Web.
This looks like a pathway, kind of.
Yeah.
A lit up pathway.
And I don't like how these guys look like boogers.
Oh, Georgia.
They do.
These ones. Okay, so point to the ones you're talking about. Yeah.
one?
Are those the ones that look kind of like mucus?
Yes.
So yeah, we call that mucoid when they're all shiny and gooey like that.
Ew.
Yeah. So the bacteria that I work with in the lab, you guys, it does that sometimes when it gets a certain kind of mutation in some of the genes.
Why is this one black?
This one over here?
This one looks like fungus.
Yeah, or mold maybe?
Yeah, more like mold.
Can we move on to the next one?
Yeah, of course we can.
Disgusting.
Disgusting. All right,
Oh, my washed
what's
hand.
this one? Yeah. So what do we think about how good of a job did we do of washing hands?
I mean, like, it's better than the other ones.
Yeah, so if
By
we
a little
counted up all of the colonies that are on there, we probably have fewer colonies on the wash hand, right?
But we
Yeah.
probably need to wash for maybe 30 seconds.
All right. You want Luna's paw?
Oh!
Oh, wow. So
Ew.
never put your hand on a dirty floor.
Yeah, pretty much. All right, so how many different kinds of colors and shapes?
I see white, a little orange right there,
Yeah, you're right. I
and
do
some
too.
yellow.
I have a question for you guys. Do some of the bacteria that are on Luna's paw look similar to some of the bacteria that are on our hands?
Yes.
A little.
Yeah. I see some similar colors and shapes, right?
Yeah.
Yeah. All right. Should we do Stella's now?
Yeah.
Ew! It looks like black fungi or mold, brown fungi, and fungi.
Oh my goodness. And do some of
And
them...
some more fungi, some mold.
Wait, guys! Look, a pink and yellow colony.
Oh my goodness. Look at that. Isn't that cool?
Look at these guys. They're all clumped together.
Yeah.
Like triplets.
Maybe they're in an alliance. Dun 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 dun.
That's actually a really, really good observation. And it's a very strong possibility, Georgia. All right. So did you guys like this? That's it. Did you guys like this experiment?
It was disgusting.
It was
and
disgusting.
Remember, never open petri dishes.
Yes.
You don't know what's on them.
So what are we going to do right now?
We're going to
Wash
go wash
our
our hands.
For how long?
20
Forever!